Okay, the topics for today, assuming that we already cover the relative more basic stuff in this course. So we already cover classes, objects, aliasing, we cover exceptions for error handling, and also we cover how you can read JUnit tests. That's what we did previously. So now we want to go just with other concepts that's also important. That's why I called it a little bit more advanced topics. We'll talk about equals method today. That's worth quite a bit of a discussion today, and we'll see lots of examples. And then later on, we're going to talk about compare to methods and also hash code. So that's for the serious lecture. Hopefully, by next Monday, we can cover everything. But let's go one step at a time. Let's now go right to the topic. Basically, whenever you talk about equality in object-oriented programming, you talk about two kinds of equality. Either you talk about equality between two addresses, or you talk about equality between the contents of two objects. So these are the two notions of equality. But we're going to see exactly how to distinguish between them. Each one of them is useful, but you want to know which one to use under what circumstance. Okay, let's do a little bit recall. Okay? A primitive type simply store a primitive value, integer, double, Boolean, and notice that string is a reference type. String is not primitive. Okay? For example, you got double, okay, you simply got simple values. That one's easy. And now you also talk about reference variable. So we have seen many examples. If you say points P1 versus person P1, right? You just talk about storing addresses of different kinds of objects, addresses. Okay? So now we have to know very clearly how we can compare. Okay, let's say we got point P1, which P1 here stores the address of some new objects, point objects. And also P2 stores just another address that is different. Okay? And now, here is the thing you want to be clear from today. Whenever we use equals, it depends on what the operands on the two sides are. Let's see. Simplest case, this might be how you started with in 1022. If both sides are simply just primitive values, you're just comparing their values. For example, you might say D1 and D2. Remember, D1 is a double. D2 is also a double. You're just comparing 7.5 together with 7.5, right? It should work, okay? Lesson number one. If you're simply using equals to compare two primitive variables, you're just comparing the store values. On the other hand, what about reference variables? In some way, you're also comparing the values. However, rather than the values of the objects themselves, like x and y, or name, age, weight, and height. You're comparing the values of their addresses. That's a critical point, okay? So now, for example, you got over here, when you say P1 equals P2, remember you can see P1 was created as a new object, and P2 was created to store the value of another new object. So now in this case, P1 equals P2 should give us false, right? Because they're different addresses. Okay, this slide here is only a review of what we have seen so far. So now here comes the question. If you look at P1 and P2 over here, if you look at P1 here, it simply points to an object where x is 2, y is 3. P2 is pointing to a different points object. However, the contents happen to be the same. X is also 2, y is also 3. So now, however, if you do P1 equals P2, that will tell us false, because they're different objects. But now we do want to allow the possibility to say, even though I'm comparing two distinct objects in the memory, but I want to somehow have a more flexible way or more customized way to say, this object for points will be equal to this object of point if the following conditions are correct. For example, you might say, in this case, if the x and y coordinates are the same, the 2 points object should be the same, right? That's a very quick overview of what we're going to see. So, having said this, okay, what we're going to do today, we'll start with an example where we're going to create two versions of the point class, two versions. In one version there, it's simply just the way it was up to now. The other versions, we are trying to redefine, or in the Java terms, overwrite the so-called equals method and see how the behavior of your program might change. We want to study both. And then we'll try to make it more general to another example. Okay, but the first thing first. Let me just give you a very quick overview over here. Okay, by the way, so this is the last example in your JUnit slides. So this is something maybe I'll try to go through either on Wednesday or next week, okay? But that one is very straightforward, okay? I'll talk about this diagram here a little bit later, okay? Let's go directly to equals. Okay, so now over here, I'm just trying to give you an overview of how we're gonna see the examples, okay? So now, what should you know, right? You should know the following. Number one, there is a class in Java called objects, okay? In the object class, you got a very small number of methods that's defined over there. One of them that we are concerned about today is called the equals method, okay? As you can see, it's an accessor method. It's simply going to return a Boolean, and then it's going to take a parameter of type objects, okay? And then it's simply got a one-line implementation. And question for you, according to this definition over here, is it trying to compare address? Okay, very good. That's the first thing to know, okay? So this definition over here, if you go to Java API, look for the object class, it's exactly this definition, okay? So here's the story. We'll talk about the keyword called extends later after the reading week. For now, let me try to just explain to you. Extend simply means we are trying to reuse certain methods, okay? For example, I'm going to present to you two versions of the points, okay? I'm just going through the big picture first, and then we'll dive into details. Version number one, I'll just use red, okay? In version number one, oh, by the way, every class in Java that you can create extends objects class by default, every class, which means, we'll put it another way, okay? Every method defined in the object class is automatically available in every class you create. Okay, you can see that. So here we talk about version number one versus we have another class called version number two. Okay, for these two classes, by default, they simply reuse or inherits the equals method from the object class. However, you as a programmer, you have the option to say either you are happy enough with the default version over there in the object class. So this is default version. If you are happy with it already, what you can do is do nothing in this version over here. On the other hand, if you think to yourself, well, maybe I don't really want to compare to see if 2 points are equal to each other just by their addresses, what you can do is you can do something called overriding. Okay, it's a special term in Java, overriding. Or informally, redefining, which means you're reusing this particular version over here from the object class by default. However, I'm not happy with it. I want to customize it. I'm redefining it. Okay, so that's why we got two versions. Don't worry too much about exactly how the equals method is defined in the second version. We're going to go over that. Don't worry. Okay. Now the big picture is, for this example, we got two versions of the point class. Both of them have two attributes, x and y, for the points. For version number one of the red, we simply are going to use the default version of equals, which boils down to be comparing references only, number one. Number two, the second version we're going to see is version number two. And that one there, we explicitly redeclare or override or redefine the equals method. Okay, you can see Boolean equals object obj and do something inside. We'll talk about what that something is in just a moment. And then it's going to give you a different behavior. Okay, that's the roadmap. Any questions? One more thing to say. At this moment, and you never have to say point v1 extends objects. You don't have to say it. It's by default. It's implicit for every class. You don't need to do it. Okay, I'm just trying to show you the relationship over here. Okay, if no questions, let's go over version one in detail. Okay, and then we'll try to give you some tester to see the behavior, and then I'll use debugger to show you a little bit, just to really convince you what's really happening. Okay, so now let's talk about the default version. Okay, again, you can see I try to give just a subset of the diagram I just show you. Again, this is the object class existing. And then this is the default version of the equals. And in this particular version 1, we choose not to explicitly redefine the equals method. Let's see what's going to happen. Okay? What's going to happen is, briefly speaking, whenever you try to say, for example, okay, let me show you. That's exactly what we're going to do. So now let's see, try to trace the code a little bit. Let's say we have a string value over here, okay, just 2, 3, okay? Let's say we got P1, P2, and P3. 3 new objects of type point V1, V1, V1. So we are talking about this particular class where the equals method will just go by the default version from the object class, right? And now, let's see this. I want you to, let's do a very quick exercise over here, okay? So now let's see what the value should be. For V1, for P1 should be 2 and 3. For P2, it should also be 2 and 3. For P3, it should be 4 and 6. Okay? Let the one that's blacked out over there is something we want us all to do together. Okay? The first two should be very easy. Okay? The first two. What about the first one? If I say print line P1 equals P2, false. Everybody agree? Right? Just different objects. Okay, that's good. What about the second one? P2 equals P3? False. Very good. Okay, it's just a check. Very good. So far, so good. Now, we have to worry about P1 dot equals P1, P1 dot equals null, P1 dot equals S, everything. Okay? So now, if you look at that, number 7, okay? So now this is why in the review lecture, in the beginning of the term, I said knowing what the context object is and also knowing how to trace the code, trace a method call is so important. You will see exactly how this can shine. Okay, we'll see. So now what I want to ask you is this. Let's say I try to execute line number 7 over here. And then if I try to execute this particular method call, okay, and we know that P1 over here is the context objects. Agree? Okay? And then, let's say this. In Eclipse, remember I demonstrate to you, if you put a breakpoint, that means the execution is going to pause at line number 7. If I say step into, it's actually going to see how exactly this equals method will be executed. Okay, so far so good? So now a question for you. I'm going to illustrate that. Let's say I put a breakpoint in line number 7, and then I launch the debugger in Eclipse. Now it paused at line number 7, I say step into. Which class would I step into? I heard objects. Objects or point V1? I tell you what the trick is. Over here you can see P1, okay, when I say P1 dot equals over here, and then P1. Okay, first of all, this is the context objects. What we said previously was, whenever you have a context objects, you want to see if this method is actually defined in that particular class. In this case, point V1. But now the problem is, you did not explicitly define equals method in this class per se, right? However, that's something new to you. In Java, everything that's defined in the object class is implicitly available to you. You can just use it. Okay, that's what inheritance is about, but we'll talk more after the reading week. Okay, so now if I say, if I pause at this point over here, if I say step into, what it will end up happening is it's simply going to go into the object class and show you how to execute this line. Okay, let's do a little bit more, and then I will show you Eclipse. So now if I got P1 dot equals P1, right? So now we know that, what's this in this case? P1, right? Context objects. What is OBJ? Also P1, right? How do you see that? P1 here. Okay, so that means this is P1. So now what you boil down to evaluating in this case will be P1 equals P1, which will give us true. Okay, are we okay so far? Okay, let me illustrate to you quickly. Okay, basically line number 7 until 11 follow exactly the same logic. If you get that one, the rest should be not too bad. Okay, let me go to Eclipse. I'll make the source code available to you after class today. Okay, so now when you see the source code available, you will see point V1, where as simple as that. you can see in this class point P1, we did not try to redefine the equals method. Okay? And then let's go to the point tester. Okay? So now what I'm interested is, first of all, you can see I created two point objects, P1 and P2. They are of type point V1, okay, version 1. And then now I'm going to put a breakpoint at line number 18. Let me pause a little bit to tell you, don't get lost. Line number 18, we are trying to call P1.equals P2. And now the context object is P1. According to line number 5, P1 is of type point V1. As we know, point V1 did not explicitly redefine equals, so we're going to reuse the version from the object class. Right? Let's verify that, and then the rest can be assumed. Okay, what I will do is, I do encourage you to use debugger. It's a really nice programming tool. If I run the debugger over here, okay, you can see now the execution pauses over here. Okay, line number 18. So now what I will do, I will say step into. Now, as soon as I say step into, what's going to happen before I click on that, what's going to happen is we'll see that we'll switch the context into this particular method. That's what we'll see. Okay? Let's go back to Eclipse over here. If I say step into, now object class, that's where we are. And then what we're doing, return this equals obj. Okay? That's exactly the version we are using. However, later on, when we move to version 2, you will see that when we try to do step into in the same place, we're actually going to see it's a different version of the equals method that will be executed. Okay, that's the essence for this example here. Okay, let's now over here, so what should that be, true or false? You can definitely try. If you go to expressions panel, you can simply type this equals obj. That will simply give you, okay, never mind. Not sure why it's throwing an error on me. But in this case, this is basically the P1 that we talk about. Okay. This over here is a context object, P1 that we talk about. And also obj just happen to be P1, okay, over here. So P1 equals P1 will just be true. Okay, let's verify that. Okay. But at least you'll be very recommended you try to reproduce at least up to here so you can see really the version being called. Okay, so now if I go on with that, you will see that calling that, it will simply give me true, right? P1 equals, in this case, the 2 object will just be the same. Okay? Okay, any question until now? Any questions? We okay? All right. Let's do something similar, okay? Line number 8. If I do P1 dot equals null. First of all, should that be true or false? I agree that should be false, but now let's be more, let's be clearer. What this will boil down into evaluating would be, we know that P1 is not the context object, right? So P1 over here, and then obj is simply just null. So we are basically evaluating P1 equals null, right? Apparently, P1 is pointing to some object, so that should be false. Okay? Similarly, can we do line number 9? 9 is interesting. By the way, everything compiles. Okay? Let me just reveal the previous answer just in case you want to refer to them. Okay, that one is also, that one is true, right? Okay, P1, and this one is false. Okay, so now line number 9 should be true or false. Okay, it's false for a very simple reason. Okay, simply because over here, what you will get is P1 dot equals, oh sorry, here. So P1 dot equals S. So that means you're basically P1 dot equals S. You will simply boil down into P1 equals S. Okay? Basically, S is simply just a string objects, and P1 is pointing to some point V1 object. They simply cannot be the same, right? It will just be false. Okay? So now let's do another one. What about 10? P1 dot equals P2. False, right? Because it will simply boil down into evaluating P1 equals P2, right? Will just be false, okay? They simply point to a different object. Okay, forgot. Okay, can we do a final one? So notice one thing here. One thing just about this line. If you look at line number 10, line number 10 is the most important line to pay attention to. Notice that P1 is pointing to this object over here, and P2 is pointing to this object over here. When we say P1 dot equals P2, even though 2, 3, 2, 3, even though the contents are the same, but now we are only reusing the default version of the equals method, which compare references only. So that's why you still get false. That's the most important line to pay attention to. Okay. Finally, can we do one more? What about line number 11? P2 dot equals P3. Okay, I heard false. Is it because the contents are different or the addresses are different? Addresses, good, thank you. Okay, so now P2 and P3, right? So now even though their contents are just different for sure, but that's not a reason for failing. Okay, so that means P2 equals P3 is going to return to you false. Okay, that's about the first version. Any question for me? Basically, the first version is trying to show you that if you do not explicitly override or redefine your equals method, you're just going to use the default version, which is just going to compare references. That's a lesson. Okay? Things will get complicated a little bit more if we try to use the customized version. That's something you are required to do for lab. Okay? But what we show in the class is more than what you need. Okay? Which is important, right? We want to do more thorough discussion here. Okay, we're going to see the second version in just a moment. Let me just go back to the slides. So when you go over the slides, this slide here just talk about the object class, right? Just about being the common class, okay? Okay, you can read it, exactly what we just covered. And this is the one-line implementation for the equals method, as we said, okay? And then we talk about, oh, this is a common error people make. Let's say this. You got integer I, integer j. Apparently, they're primitive types. And then I say Boolean, I and j are the same value. I say I dot equals j. Is it right? True or false? True, false, or something else? Well, anybody want to speak up? What's something else, if you believe?
J should be object, so it confers to object, but
yeah, exactly. So now here's a common mistake. For primitive values like an integer, the only way to compare them would be to use equals, like an equal sign. The equals method is only applicable for a reference type. Okay, so in this case, this is simply not correct because I and j are integer. Integer has no equals method. Okay, it's a common error. Be careful. Okay, so now how do you fix it? Change to equals. Okay. Let's now, and that's the version number 1. Okay, exactly what we just went over. Okay, nothing has been missed. Okay, everything. Okay. What you have to train yourself about is when we look at this line of code, this fragment of code over here, you have to know exactly how to trace it. That's the main message over here, right? So now let's consider the second case. Okay, so in the first case, just default version. Let's talk about the second case. Oh, one more thing. It's very important for you to realize when I say P1 dot equals null, this simply boils down into P1 equals null. That's the main insight, right? Because we're using the default version. Okay, there's something about the requirements for equals method. I'll go over them very quickly on the slide. They're quite obvious. Okay. Basically, now we want to move on to the second version because the first version is not so satisfactory for the following reason. When you look at line number 10 specifically, we are comparing P1 and P2. Okay? When we say P1 dot equals P2. However, even though 2 and 3 over here, the contents are the same, it will still give us false simply because it's using the default version to compare addresses. We want to change this. Okay? The way to change that is by creating your own version of the equals method. And there's some requirements over here you have to bear in mind. Let me go over that very quickly, but they're straightforward. Your equals method has to be such that, number one, whenever you say x dot equals null, it should always give you false. So by the way, this sign over here, for those of you taking the logic course, that simply means negation. Okay? So when you say some objects dot equals null, it should definitely give you false because x should not be null. Okay? So null is not equal to, something that's not equal to null should not be equal to null. Okay. And the second one is also straightforward. If you try to compare something against itself, it should give you true, right? That's also straightforward. And the third one, if I tell you that x dot equals y will give you true, symmetrically, y dot equals x should be true as well. Okay? That's something also very important. Okay? So which means it doesn't matter whether x is a context object or y is a context object. Doesn't matter. Okay? But if one is true, the other one should be true as well. Okay? And then transitive, that's simply if x equals y, y equals z, x must equal to z, right? Just what you learn in math. Okay? This slide's a little bit dry, but there's something, some criteria you want to make sure whenever you want to define your own equals method. Okay? Let's see more example. Having learned this, having seen these principles over here, let's have a look. If you want to see more about the equals method, you can click on the link. So that's the API for the equals method for the object class. Let's now consider the second version. Okay? The second version goes like this. Okay? Let's just go over them, and then we'll trace the code quickly. Basically, for the second version, we still have x and y. And then we say that we explicitly redefine the equals method. Okay? Still take objects. Okay? And then this is kind of the implementation here. Okay? We'll go over the implementation line by line in just a moment. And then we're going to run basically the same set of code, set of lines, and see if results might change. It should make a difference, basically. Okay? What I would like to do now is to go over the code over here for the equals method. Okay, that's the second version. So now notice one thing right away. In the object class, we have the equals method default. In the point v2 class, we have another version of the equals method, right? We got two versions. First of all, can you notice that? So now the question is, if we want to do something like, for example, p1 dot equals p2, where p1 is simply point v2 type. Now, which version should be called? Right? That's the question. It turns out you will simply go to that particular class that's a context object, and then go to their class, which is point v2, because you got a specialized version over there. It's going to call that version first, rather than the default version. You only call the default version when there's no redefined version. Okay, that's the principle, right? Okay, let's now have a look. Okay, again, as a warm-up. Okay, we have over here. Let me use the green. P1, P2, and P3. Okay, and P1 is 2, 3, and P2 is also 2, 3. Also, P3 is 4, 6. Okay, we got three objects, pretty much the same setup, similar. But notice that now we talk about version 2. Okay, let's try. What should be the return value for line number 5? False? Agree? I agree. This one, nothing to do with equals just yet. Line number 6? False. Thank you. Okay, just making sure. Different objects. All right. So now we have to worry about line number 7, 8, 9, 10, and 11. Okay? So now, without actually telling you exactly how to define equals method, how about we go the reverse way? We look at the method calls over here, 7, we look at 7, 8, 9, 10, 11, and to see how the corresponding part can be traced back to this method and see how it is executed first. Okay? And then that will show us what should be the correct way of defining them. Okay, let's try. Start with the simple cases first. The first one, let's use light green. Okay, number 7. Okay, so now if I do p1 dot equals p1, okay? If I step into the execution of these methods, right? As we said before, we got two candidates. Either we can go back to the default version, or we can go to this customized version. Which version we go depends on what's the type of the context objects. Write it down. If I say p1 dot equals p1, the only object that matters at this point is the context objects. Okay. So now what you have to be careful is, so now let's write this. The type of context objects p1 should be point p2. Agree? And we know that because there is there's a redefined version of the equals over there, that version is going to be called. If there's no, the object version will be called. Easy. Okay? Because equals is already redefined over there, so overridden version, redefined version is called. Version is called. Okay, so now we're going to see that in Eclipse just to be complete. So now if I say p1 equals p1, if I say equals, I'm now going to select this particular version over here. Okay, so now that means over here, what would be this? Still p1, right? That's context objects. So let's just try the very first branch over here. Okay, we know that this would just be p1, right? Okay, let me just write it aside so that's be easier. So now line number 8 will simply boil down into this will just be p1 equals obj. What's obj? Also p1, right? Over here, p1 equals p1. What would that be? True. You can see compare line number 7. Oh, that should be line number 7, right? Sorry about that. I wrote it wrong. I want you to compare line number 7 and line number 7 over here. Both of them return true, but for a slightly different reason. In the previous version, when you say p1 equals p1, it's going to execute this block of code. On the other hand, for line number 7 in the second version, it's going to execute this block of code. Okay, it's really important to realize that. Okay, any question up to now? So just one moment. The rest of the logic is going to carry on consistently. We're just going to select the customized version for the equals. Okay, question? Yes.
So let's say lab 2, right? I didn't include if this, the equals object, it just worked without it.
I think what you have to say, this equals object, you have to. It could be that maybe the test cases that was given to you didn't test for this. You have to include it. Yeah. If you didn't include it, in that case, that means if you simply pass something that's equal, you wouldn't be able to. Yeah. Mm-hmm.
So if I put it like that.
Oh, wait. You know, for that question specific to lab 2, it's more like about the simplified version for the equals. I would say we kind of go with this particular template that's recommended by official Java. So we just go with that version over there. But if you want to talk about simplified version, I'll rather talk about in a later lecture. So people are still picking up the ideas. Yeah. Okay, so now let's go a little bit further. Okay. You might realize this particular template over here can also be simplified in another way. You will see that. Okay? But for now, let's just learn it. Okay? Okay, let's go for the second one. Okay, I'll go to Eclipse in just a moment. So now, the second one, let's use blue, 8. So now we're going to say p1 equals null. Right? Again, we're going to select this version of the equals over here. Okay? So now, p1, so that means we're going to execute this line specifically. Right? Agree? Okay? Oh, by the way, if you think about the blue case, what's going to happen is p1 and null. So that means obj is going to be null. What about the first condition to be checked? When I say this equals null, would that be true or false? False, right? That means this part will not be executed. right? That's just bypass. So bypass the first condition. That is why this is not executed. We'll simply go for obj equals null. So line number 8 will boil down into obj is simply just null over here. So we'll say null equals null, right? Can you see that? Okay, what's that? Well, first of all, if you try to trace this part, null equals null will give you true, right? That means you have to return false. Okay? What's the logic over here? Okay? Again, let me highlight this line here. That's really important to see. If you look at that, P1 dot equals null. What's the intuition? Number one, P1 is not null. Agree? According to line number 2, P1 is simply not null. And you're trying to compare P1 that is not null with something that's simply null. That should give you false for sure, right? And the way we do that is by saying, if you try to call the equals method over here, where the argument over here is simply just null, well, unconditionally give false. Because if you compare something that's not null and something that's not, they're not equal. Okay, that's the logic for the second condition over there. Okay, questions? So far, the first two cases are easy, right? Basically, the first one is about to say if you compare the object with itself, it should be true, right? The second case, obj equals null, because you know that the context object should not be null. So comparing that against something that's null should give you false directly, right? So that's the two cases. All right, so now let's go to the part that's a little bit trickier, okay? Let's now go to another point, okay? Let's look at line number 9. So now we're basically saying P1 dot equals S, okay? So now, in some way, this is a very trivial result to return because you're comparing apple with banana, agree? Because P1 over here was declared to be point V2. S over here was declared to be simply string. In general, you cannot compare two objects that are of different types. It should be false automatically. Okay? So now this is exactly what the conditional is doing here. Let me show you. So now if you try to execute line number 9, okay, what you will do is, line number 9, what they will do is you will try to say, so you go to this if branch over here. Okay, I'll write it down. This is simply P1. P1 dot get class equals, and then we'll say S, which is over here, S dot get class. Okay, what's get class over here, right? That's something you will learn a little bit later when we talk about inheritance, but let me make it short. The way we trace the objects, for example, when we create P1 over here, remember there's a title I put over here about the type of the objects. You can think about get class is going to return to you that title. The more formal term is called dynamic type. Okay, I'll write it down, but you don't have to worry too much at this point. Get class is going to return back to you the dynamic type of the objects. Okay? Dynamic type simply means, remember the way we change the arrows around the objects. We can say now P1, rather than pointing to this object here, P1 can point to some other objects. So the dynamic objects of a particular point can just change all the time. Okay, let me just show you what I meant. In general, if you got P1 pointing to some objects over here, right, its dynamic type is simply whatever title it is, right? Later on, you might change this to be another object. And in general, this should be the same. However, in some cases, especially if you talk about inheritance, this type may be different. This is something I will address thoroughly once we talk about inheritance. For now, all you got to know is when you say get class, it's simply going to tell you what type it is for the objects at that particular time of execution. That's it. Okay? I'll write it down. Okay? So now all you need to know is when I say let's say object O dot get class returns the type of objects pointed by O currently, which means it might change later. Okay? So now let's go back here. So now question for you. What should be P1.getClass in this case? P1.getClass point v2. Agree? Okay, very good. So that will simply give back to you point v2. Okay, what about S? String, right? Because that's how we create it, right? It's a string object, okay? It will just be a string. And now we're basically comparing if these two types are the same. In this case, they are not. Okay? So that means this particular comparison is simply going to give us false. Okay? More specifically, I missed one detail over here. Notice that how we define this particular condition over here. If you look at that, we put not equal to. Right? That's important. We're saying that if the context objects and the argument object are pointing to different objects, that means they cannot be equal, just return false. Okay? So now, let me just modify that just a little bit. So now, if I have, let me go back here, not equal to, so now the whole thing is going to return back to me true, right? Because point v2 not equal to string should be true. Okay, so now overall it's going to be true. That means I'm going to satisfy this condition over here and then return false, because you're simply comparing two objects of different types. Okay? Go ahead.
What is the return of the getClass?
GetClass is going to give you a string. Actually, it's, I got to check. It's either going to give you some class. There's a class called class in Java, either a class type or a string. I kind of forget. I can check that. Yeah. Basically, what you're comparing over here is whatever type it is for P1, compare that against whatever type it is for S. If they are not the same, that means you're calling equals on two objects of different types. You got to return false right away. Yeah. I can double check the type. Yeah. Could be it's not string. Yes.
Can we use instance of instead?
Use instance of. Instance of would be tricky, okay? You can ask me again this question a little bit later. The answer is no, you cannot. Because it will be tricky to actually use instance of. Because you have to know, once you use the instance of, you have to somehow do more detailed cast accordingly. But you can ask me later, yeah. Okay? Okay, any other questions? Try and catch block. Actually, try and catch block is not applicable in this context, because remember, the only reason you would do try and catch block is when you are trying to make a particular method call, it has the potential to throw some exception. But here we're not making any method call, right? Okay, good. Yeah, basically, I see what you mean. Let me just go a little bit further, okay? The diagram is a little bit annotated, so I'll go for a new page. Okay, let's now focus on the definition over here, okay? Okay, that's an equals method. You're asking the following, okay? Good question. Let's say we are able to get to this particular point, let's say, the flow of execution, right? What does that mean? That means this particular condition is false. Otherwise, we would have returned true, right? Also, this condition here also should be false. Otherwise, we would have returned false. And also, this condition over here should also evaluate to false. So otherwise, we would have returned false. Only when those three conditions evaluate to false can we actually reach this line. Do you agree? Okay, good. Let's think logically. If every one of them simply evaluate to false, that corresponds to the following. Okay, let me write it down. That means, number one, this is not equal to OBJ. So they do not refer to the same objects. Okay? Number two, OBJ is not equal to null. That means you're comparing something, the context object, against something that's not null. Right? Number three, over here, this dot get class equals obj dot get class. Okay, so these conditions are all true if you can reach star. Okay, star is over here. Okay, we're thinking logically here, right? So now, what this line over here means is it's guaranteed at this point the type for the context objects and the type of the arguments obj are the same type. They're simply the same. So when you try to do a cast, which I'll talk about, it will just be fine. It's guaranteed. Okay? Although I did notice that there's a small typo over here. I'm going to fix it. Okay? So this guy over here should be point v2. v2. Sorry about that. Okay. I'll talk about the cast in just a moment. Okay, guys, I think what I just discussed in this clean slide is very important. Basically, I'm saying that because, I'll get to you. All the previous 3 if statements over here, if any one of them is true, we would have returned from the method already. Since we haven't returned, that simply means all the conditions over here are simply just false. And because they are all false, it guaranteed. Now the type of the context objects and the obj are simply the same. So now we can safely do some cast. And I'll explain what cast really means in just a moment. Question?
So get class compares types, but if you had like this was from point V2 and obj was an object from
Yeah.
V1, would that be true?
Good question. Yeah. The question was, actually, wait, I do have one example over there, but I'll just mention you briefly. The question was, let's say, what if I say, I'll write it down, okay? If I got point V1 over here, let's say P1 is new something over here. I say point, notice that V2, and then P2 is new something over here. If I say P1 dot equals P2, without knowing what the new expression over there is going to initialize the attributes into, do you think this is going to return true or false? Okay, false is correct. However, the false is returned from which line? Well, thinking this way, right? So now P1 is a context object. It is this. If you say get class, it's going to give you point V1. On the other hand, P2, which is obj over here, is if you say P2 that get class, it's going to give you point V2. Remember, these two classes have nothing to do with each other. They just have similar name, nothing else. So now, when you try to evaluate this particular line over here, this that get class is going to give you V1. Obj that get class is going to give you V2. They are not the same. So this inequality will evaluate to true. So return false right away. Good question. Nice. Okay, so now let's talk about the cast over there. Okay, let's talk about the cast. And let me use another slide. The cast will have to be discussed much more thoroughly when we talk about inheritance. I'll just give you just enough information to understand to some extent what this really means. Okay, again, the same equals method, except I have to, that's the benefits of point V2. Okay, it's now fixed. Okay,
The other one,
I should do.
untitled statement.
Yes, thank you. Thank you so much. Let's be 100% correct before we have discussion. Okay. Yeah. Okay. Okay, guys. Let's start the discussion from here. We want to understand what this cast really means, especially why do we need it. Okay. So now, again, up to this point, we know that this and obj, okay, are the same type. Okay, so now let's say this. What if I don't use a cast? Let's say, what if I don't do it? Can you say hypothetically, okay, rather than this block of code, let's call this version 1. Okay? I'm going to give you version 2. Rather than creating another variable called other, I'm going to do the following. I'm simply going to say return over here this .x equals, I use obj directly. Okay, I'm going to write it down. Oops. It's hard to do it perfectly. Yeah, never mind. Okay. This .x might be okay if I try to do from here. You know. obj.x, okay? And this .y equals obj.y. Okay? You can see the difference between version 1 and version 2 is I don't do any cast. I simply use obj directly. That might be the initial thought some of you might have. I agree, it's intuitive. Okay? Now, is version 2 going to compile?
No.
Okay? It's not going to compile. And for those of you who know the reason, can you tell me what the reason is? What's the reason?
It checks if the x variable is in the object class.
Mm-hmm.
Returns a false.
Yes, good. Okay, let me just repeat what you just said. That's exactly correct. Okay, so this is something I'll just give you a little bit taste about what this really means. I want you to pay attention to the declaration over here. The way we declare the parameter is to say objects obj. Okay? More precisely, we're saying that obj has the declare type objects. Okay, so far so good. That's how we declare that to be just objects. So because of this, we can pass any objects as the argument to the parameter. That is why previously, let me go back a little bit. When I say p1 dot equals s, that will compile simply because s over here, which is of type string, it will be accepted as an object. A string is an object. Everything is an object in Java. Okay, that's fine. Okay, let me go back here. Now, the consequence of obj of being object type has a following limitation. Okay, it's really important to know. Okay, let me write it over here. Java compiler only allows attributes or methods defined in the declare type of obj, which means now because we declare that to be objects, so now the declare type is simply just objects. And now, does the object class has x and y? No, because x and y are specific to the point v2 class. They don't belong to the object class. That is why it wouldn't compile. Okay? So this is something to do with the static type checking, which we have to go through when we talk about inheritance. Okay? For now, let me summarize what you should know at this point. Okay? Number one, look at the declaration for the parameter over here. You will see that over here, we declare the parameter obj of type objects. That's the most general type you can put. Okay? So that would simply means whenever you refer to obj, the methods and attributes you can call on obj should always only come from the object class. This means it excludes the possibility of x and y. Now, the cast would be very useful. You can think about the cast is more like a programmer's option to overrule the compiler. So now the compiler is complaining that, you know what, obj, it doesn't really support the x and y attribute because obj may not point to a point v2 object at a runtime. It might point to a string. Now, me as a programmer, I can tell the compiler, just trust me, just go ahead and do it. Okay? The way to do that is by using this line over here to say, obj over here, I'm going to somehow so-called cast that into the type point v2. As soon as this is done, assign this object here to another thing called other. So now, as far as the compiler is concerned, so now other, you can call any attributes or methods from point v2 class. Okay, let me just show you something here. Okay, quickly. Imagine that this is obj. Obj is now pointing to some point v2 class, for example. However, obj was declared to be objects. So as far as the compiler is concerned, they wouldn't allow you to call x and y. Okay, just for the compiler, the limitation. What we do instead is to say, over here, now create another variable called other. And then now the type for other is simply going to be point v2. Notice the difference of the type over here, right? And now it's simply going to point to a cast version of obj. So now it's simply going to point to wherever obj is pointing to, right? We talk about such aliasing. But now obj and other, even though they are pointing to the same objects, but to the compiler's point of view, they're different. For obj, you can only call attributes and methods from the object class. On the other hand, for other over here, because of the cast we did, you can call anything that's specific to point v2 because we have done the cast. Okay? That's what this line is saying. For now, you just have to remember whenever you want to do a cast, you have to cast into the type that you want. In this case, because I want to do equals method for point v2, so I want to cast that into this type. Okay? Now, after this, you can see that we can say this.x, this.y, that'll be okay because this is point v2. And now what about other x, other y? You'll be fine as well because other has now got the type point v2. Okay? That's like all the lines in the equals method, right? I know that there's some details here I cannot really explain thoroughly right now, but I think it just gives you enough information. So when you do the definition, at least you know how to write the code to really fully appreciate exactly what do I really mean by declared type. What do I really mean by dynamic type? What do I really mean by casting? We have to wait until we cover inheritance. Don't worry, we're going to spend 3 weeks on that. Lots of stuff to cover inheritance. That's the most exciting part for this course, actually. So get ready. Okay, guys. As far as the definition is concerned, any question for me? Okay. Okay. I promise I'll come back to here with lots more details. Okay. Yes. You're talking about, okay, I'm not sure exactly if I got your question correctly. You're basically asking about this line here, right? Okay. Basically, this is saying if the context object is pointing to the same object as obj, that means you're referring to the same object. An object must be equal to itself. That's why we're just returning true unconditionally. Yes, exactly. So now the next line, it's a good question. Okay, it's one of the exercise questions for you. Let me just carry on with that. I think it's relevant. Okay, okay. Let me just again copy and paste this line over here. I have a question for you. Okay, so now I wonder. Okay, that's the correct definition except for point v2, right? Except for that. Okay. I wonder if it would be appropriate for me to add the following line, okay? Can I just insert a line over here? I say if this is this equals null, and then return something. Return something, either true or false. My question is, would it be wrong or inappropriate if I simply insert this line? I say if the context object, well, what's the rationale of adding this line? I'm just being symmetric. Here I'm saying if the object's arguments is simply null, I'm going to do something. Of course, I got to handle if the context object is null, I got to do something else, right? That's the rationale for putting this. But now, is there any problem for putting this line? I heard redundance, okay?
Should get a pointer exception in the first place.
Aha, very good. That's very nice. The answer, the response to this is nothing wrong as far as the compilation is concerned if you put this line. Logically, that simply means you're not understanding the issues 100%. Okay, let's see why. Okay, what you just said is exactly right. The answer is, let me put it down and then I'll illustrate to you. Okay, you got to think again logically, right? So now over here, this it will be redundant because a null pointer exception would have occurred already. What do I mean by that? Let's see. So now let's say this. We got point v2. P1 is new something, right? After this, I say P1 is assigned to null. That simply means P1 is now simply pointing to nowhere, okay, up to now. And then I simply say P1 dot equals, I can put any objects, what about just junk? It will compile, not a problem. If we try to execute this line over here, what will we get? It's more about a sequence, right? Think about what's going to happen. Because in this case, P1, which is a context object, is more or less satisfying this particular condition over here, right? This is more like a P1. However, think about what's going to happen. Because we got a dot notation over here, that means the first step is going to look up where the object is, objects pointed by P1 is. Do we have such objects in this case? No, because P1 is simply pointing to null. So that means as soon as you try to do this operation over here, you'll give your null pointer exception already. You don't even get a chance to actually investigate this particular block. That is why this is logically redundant, because you will never get to this point. Well, or this is so-called a death code. You will never get true in this case. Okay, that's one of the exercises I put on the slides. Make sure you understand this part. Okay, maybe not in tomorrow's test, maybe in lab test 2, I can simply ask you, why did we not put this line here? You want to somehow show your understanding by explaining. Okay, that's about version number 2. I want to do one more illustration quickly on Eclipse, and then we can move on to more examples. Okay. Okay, so that's about version number 2. Okay, we have covered all of them. Okay. Okay, so one more thing to show you before I go to Eclipse. Okay, so now if I go back to this original place, okay, so now, there's one thing I want to finish over here. Can we look at line number 10? If you compare line number 10 over here, okay, if you go back to the previous place, I said you should also pay attention to line number 10. In the previous place, where we talk about point V1, and when we say P1 dot equals P2, even though their contents are the same, but because they're different objects, so that'll be false, right, in version 1. Now, line number 10, the same line, but now the object that we're talking about has become point V2. Now, is line number 10 going to give us true, false, or null pointer exception? I heard true. Okay, if you got a sense about it might be true, that's good. First of all, P1 is a context object, agree? So that means P1, you can look at that. P1 is of type point V2. Since you're calling the equals method, first of all, we'll see if you got a customized version already. You do. So we're going to call that version. And that version there with P2, okay? P1 and P2, they're simply of the same type, right? So that means we will go all the way to over here after the cast, right? So what we will execute is this block over here. We'll simply say P1.x equals P2.x and P1.y equals P2.y, right? Do a pairwise comparison of the attributes. They'll give you true, right? That's the critical difference between the two versions. Really is to say, when two objects are distinct, they got different addresses. However, if you got a customized version of equals, you got a chance to have them return true. That's usually what you want, right? If you want to, for example, if you want to compare two nickel objects or two die objects, right? That's exactly what you have to do. Okay? Questions? Okay. Let me do a little bit illustration quickly. Okay, in case you want to reproduce this on the Eclipse very quickly. Okay, so now we talk about two versions of the points, right? Let me go back to point tester over here. Okay, let me remove the previous breakpoint. If you look at line number 43, okay, you can see line number 43 we say P3 dot equals P4. Okay, you can see P3 and P4, they are declared line number 30. So they are now of type point V2. I just want to show you the version of equal that's going to be called. Okay. So what I want to do is notice that we got a breakpoint 43. Okay. And then I'll run the debugger over here, and then we pause at line number 43. Okay, now question for you. As soon as I say step into, it's going to step into the equals method. But now the question is it going to step into 1 or 2? 2, okay? That's the main message from the long discussion, okay? Because that's an overridden version, redefined. So now if I say step into, boom, point V2, right? You can see the context now is point V2, right? That's exactly this equals method we are showing, okay? So if you want to debug the equals method for your lab 2 or future labs or your lab test, that's something you can consider using, breakpoints and debugger, okay? Let me just go on with more examples, okay? Okay, so this slide, basically everything we have said is in the slides, okay? Just talking about what does it really mean when you say two objects are equal, right? Basically, if they refer to the same object, they should be true unconditionally. Otherwise, you gotta do some other checks here. Basically, every line said here in the bullet points is kind of informal. They can be translated to some line of your equals method code. We have gone through them already, okay? I'm not going to waste your time. Okay, now this is exactly the exercise we just did, right? Why did I not put this equals now, right? We already explained that too. Okay, this one we can also go bypass. You can read the explanation over there. Okay, so this slide here basically try to explain to you what this .get class and also the cast, right? We also talked about it already in the example, so you can also go over them. Okay, the only thing I want you to draw your attention is the green one. Static type. Basically, everything you have seen so far, whenever you see you declare P1 to be of type point V1, declare type also has a name called static type. When we talk about inheritance after the reading week, you have to distinguish between static versus dynamic. And the static over here has nothing to do with the static keyword in Java. Nothing to do with it. That's why it's a bit confusing. But you're a scientist, you should really deal with all the possible sorts of confusion. Okay? Okay, everything has been said. Okay, how do you do a cast? Okay, let's now do a little bit more reinforcement over here. We got about maybe 10 minutes or so. Let's see how much we can do. So now we talk about two notions of equality, right? We talk about reference equality, and also we talk about object equality. Okay. Oh, okay. When you go over the iPad notes, this one just again summarizes what you should really look at. We got two versions of the point class over here, and then specifically you want to look at line number 10. Why one is going to return false, the other one is going to return true for different reason, right? Okay, that's something I want to draw your attention to when you review. Okay, so now we're going to look at something to distinguish between reference equality versus object equality. Okay, whenever you say reference equality, that simply means you're using the equal to compare addresses. Otherwise, you're using the equals method. But now the tricky thing is, it's not guaranteed that every class has already redefined the equals method. It's really up to the developer. Okay, but I'll say typically they would, typically. Okay. And for your lab test number 1, next Wednesday for the programming, you will be expected to define some equals method. You will be. Okay? You have to follow through the birthday book example. Okay? So now we got P1, P2, and P3. Let's do a little bit exercise over here before I show you something on the iPad. So we got point V2 over here, right? So now, line number 4, easy, true or false? Did somebody say false? Maybe I heard it wrong. True. I'm pretty sure you meant true. What about P1 dot equals P1? Okay, I'm gonna help you a little bit over here. Okay, let me just give me one moment. I'm gonna paste. Would you agree, first of all, which versions of equals will be called? Object version or point v2 version? Point v2, right? And notice that even if I change the type to be point v1, it will still return true in this case. However, for a different reason. If you look at that, it's going to return true simply because it's going to execute this line over here. Right? Okay, good, for a different reason. P1 equals P2 should be false. Thank you. Now P1 dot equals P2. Okay, now P1 dot equals P2, first of all, P2 is not null, and also P2 has the same type as P1. So that means we'll go all the way to over here. In that case, it's going to compare P1 dot x, P2 dot x, P1 dot y, P2 dot y, right? It's going to give you, well, true, right? Very good, okay? P2 equals P3. Thank you. Different objects. P2 dot equals P3. Well, this case, now, why did they fail? Why would it return to false, right? Now, that means we are basically also reaching this line here because P3 over here is also of type point v2, the same type. When we get to here, we're going to say P1 dot x and P2 dot x and P3 dot x. So P2 dot x, P3 dot x, okay? I believe they're already different, right? P2 dot x is 3 and P3 dot x will just be 4. False already. So false for a different reason, right? So what I prefer to asking you is not to really see what the output is. That could be important. I want to say, okay, I know that line number 9 is going to give me false. However, which line from the equals method actually return this? Yep, if you simply tell me this line returns the false, wrong. If you tell me it's this line that returns the false, wrong. It should be exactly this expression here that returns the false. When you say P2 dot equals P3, okay? You see my points. Okay, so now let's do a little bit exercise for you. Okay, so now let's go back here. Okay, everything we have gone through, right? So you don't have to worry about the blackout part, that's fine. I want you to look at the orange box over there. Okay, I'll go over there with you and I'll ask you. So now, let's say two objects are reference equal, which means they have the same addresses, okay? And two objects are contents equal, which means they may or may not have the same addresses, but they have the same attribute value, like x and y, they're the same, okay? A and B. So these are the two notions of equality in Java, okay? A and B. So now, I have two things for you to consider. Number one, can I say, if A is true, then B is always true? Can I say that? Okay, good. What does that really mean? For example, if I know that P1 and P2 aliasing, they point to the same objects. So that means when I say if A is true, for example, P1 equals to P2, in that case, of course, I know P1 dot equals P2 will be true no matter what, because they're comparing the same objects. Okay, that one's easy. What about the second one? Can you give me a counter example using the example above? Okay, I will just wait for somebody else. I know you're very keen. Bear with me. This is really important, actually. Okay. Number two, I'm saying, so that means if I know that two objects are contents equal, for example, I shouldn't say for example, because that's something you want to answer me. If two objects have the same contents, it doesn't necessarily mean they are the same objects. Give me an example from the example there. Yeah, exactly. Okay, so now let's write it down. Okay, it's really important for you to see that. Okay, now in this case, you can see for P1 and P2. So when I say P1 dot equals P2 is going to give me true because 3, 4, and 3, 4. However, P1 equals P2 is not necessarily true, right? Because they might refer to different objects. Okay? The main message from here is you want to know the reference equality and versus context equality, right? For those of you who's taking a logic course, A implies B. B does not imply A in general if you're taking a logic course. Okay? Do we have a few minutes? I think we do, right? Okay, a few minutes. Okay, after this, let's talk a little bit more. J units. Okay? So now let's go over the principle over here, and then basically everything about equals has been covered. Okay? Basically what's left. I want to go over just these two slides about how you can use J units first of all. And then we'll do more examples on Wednesday, and then we'll do a slightly more complicated example. For example, how can you define the equals for point collector when you got an array? Okay, let's just spend a few minutes going over this with you. Okay, so now there is an assertion in J units called assertSame. Okay, you got obj1 and obj2. Basically, it's just asserting that if they are the same references, the same addresses. So equivalent to assert true, obj1, obj2 equals, the same. Okay? Okay? Similarly, your double negation, you're saying that it is not the case that they are not pointing to the same objects, meaning they are pointing to the same objects. Either way. Okay, so now very easy. So now let's say we got P1 and P2. Okay? And now P3, aliasing. That's something you should know very well for tomorrow's test, I hope. AssertSame P1, P3. Should it be pass or fail? Okay, what it will boil down into is to say P1 equals P3, right? Pass. What about P2, P3 here? You should fail, right? Really? Yes? No? Right? Only P3 and P1 are pointing to the same objects. P2 is still pointing to a separate object, right? So now if you say P2, P3, yeah, different objects. Now for this, I assume you're quite comfortable with drawing diagrams, so I'm going to skip that part. If you got trouble, feel free to speak to me, okay? You need some help. Okay, assertSame is very simple. Now, assertEquals, that's the tricky part. Very tricky. Now, for expression 1, expression 2, number 1, they can just both be primitive, or they might be reference type. For reference type, has the class redefined equals? Has it not? Has it? Okay, that's the cases we're going to talk about. Let's go over the cases. We'll do example on Wednesday. Okay, just give me 2 minutes. If it's simply P1, expression 1, expression 2 are simply primitive, you will just do equals, right? Just not addresses about value. For example, if I got I and j, 20 and 10, if I say assert equals ij, fail, pass, fail. Different values, easy for the primitive case. So now the tricky case really is about assert equals when expression 1, expression 2 are reference type. Let me go over the principle with you first of all, and then we'll do examples on Wednesday. Okay, quickly, just one slide. Now, the principle to remember, if expression 1, expression 2 are simply reference type, saying assert equals is the same as saying expression 1 dot equals expression 2. I repeat, it's expression 1 dot equals expression 2, not expression 2 dot expression 1. Context object is important. Okay? We'll see examples where you try to swap the order, things might behave a little bit differently. Okay? So now, it will be expression 1 being the context object and expression 2 being the arguments. Okay? So now, case number 1. Let's say expression 1 over here is simply an object of type point v1. Okay? In that case, point v1 has not redefined the equals method. In that case, it will just be the same as assertSame, just using the default version of the equals. Okay? That's case number 1. And example, we can go through that next time. Okay, final case. Case number 2. Let's say expression 1 being the context object, let's say it's of type point v2. In that case, the equals method is redefined. In that case, you're going to call that particular version, right? In that case, you will simply just call obj1.equals obj2 now is going to call which version of equals? The customized version you define. Okay, and then some more examples over here. So I will suggest go over example on this slides only before Wednesday. Okay, and then we'll continue from there.